Okay, so good morning, class. Welcome back. So in this recording, we're going to take a look at section 10.2, hypothesis test for a population proportion. Okay, so this is going to be the first hypothesis that we work together, right, for chapter 10. Okay, so after we talk about section 10.1, which it give you the look like the basic introduction, the ideas or the definition of the hypothesis test. Now in this section 10.2, we're going to take a look at the procedure, the step-by-step, how you're going to complete a hypothesis test. Yeah. So we have the outlines of a hypothesis test, but not the detailed implementation. So what is the exact procedure to get to the conclusion of either do not reject or reject the conclusion? Yeah. So what's going to be the step-by-step? What's going to be the calculation that you need to do in order to go to the conclusion of either do not reject the known hypothesis or reject the known hypothesis? So we're gonna keep going, right? So I'm gonna skip this example. We're gonna go straight to the procedure for the hypothesis of a hypothesis test for a population proportion. Okay, so let's take a look at the summarize. What is the ideas of a hypothesis test? Yeah. So understand the logic of hypothesis test. So in the ideas of the hypothesis, how we're gonna come up with the calculation, or what's the calculation that we're going to do in order to get to the conclusion of either reject or fail to reject the known hypothesis. Yeah. So when the observed results are unlikely or unusual under the assumption that the known hypothesis is true, we say that the results is statistically significant. When the results are found to be statistically significant, that means we found enough evidence to reject the known hypothesis. So that's going to be the logic of hypothesis testing. So based on the given sample, we're going to do some calculation. And if we can find out that the results of that samples is statistically significant under the assumption that the known hypothesis is true, then we have enough evidence to reject the known hypothesis. So unlikely or unusual. So how can we know that's going to be unlikely or unusual? So if you guys remember the unusual event from chapter 5, right, when we talk about the probability calculation. So unusual, which means that the probability is kind of low. And how low is the probability? So once again, in order to determine how low is the probabilities or how unusual it's going to be, then we have to base on some of the values of the alpha, the significant level alpha. So that's going to be the idea or the logic of hypothesis testing. Yeah. So there are three equivalent ways to perform a hypothesis test that are going to take you to the same conclusion. The methods are the classical method, the p-values approach, and the confidence interval approach. So in this section, we are going to use only one of them, which is the easier one, which is the p-values approach. Okay. So in order to get the conclusion of the hypothesis of either reject or fail to reject the known hypothesis, we're going to base on the calculation of the p-value. So what is the p-values? So the p-values approach is if the probability that the sample proportion is extreme or more extreme than the 1 of 10 is unusual. So if the probability is unusual under the assumption that the known hypothesis is true, then we're going to reject the known hypothesis. So that's going to be the idea for the p-values approach. So based on the sample proportion, we're going to do some calculate of the probabilities. And if that probabilities is unusual, so then we can say that we have enough evidence to reject the known hypothesis. So that's the idea of the p-values approach. So the p-values approach that we're using, there is a shortcut in the calculator that you might use it that can help you to answer, to do the calculation for the p-values. Okay. So let's talk about the hypothesis test or the procedure that you have to perform to get to the conclusion of either reject or fail to reject the known hypothesis. So it's similar with the idea from chapter 9 when we talk about the confidence interval. So before we can actually perform the hypothesis test, we need to check the requirement. So let's talk about what's going to be the requirement that we need to have before we can perform the hypothesis test for population proportion. So there's going to be tested claims about population proportion with the large sample size. So this is the first possibility when the sample size is large enough. Yeah. So recall that in a sample size n with x successes, the best estimate for the population proportion is the sample proportion p hat. And then p hat equal x over n. So where x is the numbers of individuals in the sample with some specific characteristic and n is the sample size. So the best estimate for the population proportion is the sample proportion p hat. And the way that we calculate p hat, we're going to take x over n. So x is going to be the numbers of individual with some certain characteristic, and then n is the sample size. Okay. So what's going to be the requirement that we have for this hypothesis test of population proportion? So if a claim is made regarding the population proportion, we can use the p-value method to test the claim provided that. So the first requirement, make sure that the sample is a simple random sample. So let's make sure that this is a simple random sample, which means that the sample that we selected is going to be at random. The second requirement is n times p0, 1 minus p0 have to be more than or equal to 10. Where p0 is the assumed values of the population proportion, or p0 is the value that we have it in the hypothesis test. So p0 is the value that we have in the hypothesis test, the known hypothesis and the alternative hypothesis. So that's going to be p0. The third requirement is the sampled values are independent of each other, or the sample size have to be less than or equal 5% of the population. So the sample needs to be independent, or the sample size have to be less than or equal 5% of the population. So one or the other. Okay. So that's going to be the three requirements that we have before we can do the hypothesis test. And once again, in this case, we're going to take a look at the hypothesis when the sample size is large enough. So large enough, which means that the second condition should be true. Okay. So that's going to be step number 0. You need to check the requirement first before we can actually jump to step number 1 of the hypothesis test for population proportion. So after we check the requirements, and if they are all good, then we can move on and talk about step number 1, which is determine the known and the alternative hypothesis. The hypothesis can be constructed in one of the 3 different ways. So we have 3 possibilities, right? So for the known hypothesis, we're going to assume that the population proportion P is equal some values of P0. Okay. So the population proportion P is equal P0. For the alternative hypothesis, you have to take a look at the claim that we have in the question to determine what inequality we're going to use it for the alternative hypothesis. So when we have P0 not equal P not equal P0, then that's going to be two-tailed test. When you have P less than P0, that's going to be left-tailed test. And then when you have P more than P0, it's going to be right-tailed test. So based on the wording of the question, you have to select the corresponding inequality so we can complete the alternative hypothesis. For two-tailed test not equal, left-tailed test less than, and then right-tailed test more than. So P0 is the assumed values of the population proportion. So this is the value that you want to test. So P0. So that's going to be step number 1 to determine the known and the alternative hypothesis. Now, after we got step number 1, let's move on to step number 2 then. So what's the second step for your hypothesis test then? So step number 2, we select the level of significant alpha. Okay, so select the level of significant alpha based on the seriousness of making type number 1 error. Okay, so alpha typically should be given within the problem. If it's not given, then you might use an alpha is equal 5%. 0.05. Okay, so that's going to be step number 2. Select the level of significant alpha based on the seriousness of making type number 1 error. I hope that you can remember type number 1 error from section 10.1, right? Now, step number 3, we're going to calculate the test statistics. So we're going to use in this provided formula to calculate the test statistic. Yeah. So Z0 is equal P hat minus P0 divided by the square root of P0, 1 minus P0 divided by N. So in this calculation, P0 is the value that we have from your hypothesis test. And then P hat is going to be the sample proportion X over N. And then N is going to be the sample size. So that's going to be step number 3. We based on the formula, calculate the test statistic. Yeah. So after we got the test statistic, now we're going to calculate the next step, which is the p-value. So for the calculation of the p-value, you have to take a look at these alternative hypotheses. Yeah. So step number 4, you're going to draw the standard normal curve. You guys remember standard normal curve, right? So draw the standard normal curve and obtain the p-value using the shortcut 1 proportion z-test. So this is going to be the shortcut that can help you to calculate or to get the answer of p-values. Yeah, so the probability values. Yeah. So if we're going to get the two-tailed test, then the p-value is equal 2 times the probability that z more than the absolute values of z0 was the test statistic. Yeah. If we're going to get left-tailed test, then the p-values is equal the probability that z less than z0. And if we're going to get the right-tailed test, then p-values equal the probability that z more than z sub 0, which is the answer for the test statistic that we have from step number 3. So you might use the shortcut 1 proportion z-test to get the answer for this step number 4, calculation of p-value. So what is the step-by-step that we might use it to get the answer of p-value using the shortcut 1 proportion z-test? So you're going to go to the stats option and you're going to go to the test. And then after that, you're going to go down to the option 1 proportion z-test. So let's take a look at the calculator then. So we're going to go to the stats option and we're going to hop over to the test option. And we're going to go down to option number 1 proportion z-test, option number 5. 1 proportion z-test. Yeah, so 1 proportion z-test. So you're going to hit the enter key to select that option number 5 then. So after you select the 1 proportion z-test, you have to put the p0, right? So p0 is the value that we have from the hypothesis test. After that, you input x, right? So which is the numbers of individuals that have some certain characteristic. And then after that, we're going to put n, which is the sample size n. And after that, we're going to select the alternative hypothesis for two tail not equal, left tail less than, and more than for right tails. And after that, we just go to the calculation and we can see the output from the calculator. We're going to try this shortcut when we get to an example then. So that's going to be step number 4, calculate the probability. Yeah. So this is going to be step number 4, calculate the p-values or the probability value based on the test statistic. Yeah. Now, after we got step number 4, now we're going to go to step number 5. So step number 5, what we're going to do then? Okay. So for step number 5, we're going to compare p-values and significant level alpha. Compare p-value with alpha and state the conclusion. So whenever we have p-value is less than alpha, we reject the known hypothesis. Yeah, so if p-value from step number 4 is less than significant level alpha from step number 2, then we're going to reject the known hypothesis. If the p-values is more than alpha, then we fail to reject the known hypothesis. If p-values is more than alpha, the significant level, then we fail to reject the known hypothesis. So that's going to be step number 5. So after we got step number 5, then we're going to go to step number 6, right? Answer the question of interest in the context of the problem. So you might go back to section 10.1 and take a look at how we state the final conclusion, right? So if you're going to reject the known hypothesis, there is sufficient evidence. If you fail to reject the known hypothesis, there is insufficient evidence. You might need to take a look at section 10.1 to review how we state the final conclusion. So that's going to be the step-by-step how we do the hypothesis test. For this recording was to test the hypothesis of population proportion. So you might stop the recording for a few seconds and review the summaries or the step-by-step or the procedure that we have for the hypothesis test of population proportions. So to recapture what we have so far for the hypothesis test, right, there should be 7 steps, right? So there should be 7 steps for your hypothesis test. Step number 0, you're going to check the condition. Yeah, so step number 0, check the condition. Step number 1, you're going to determine the known and the alternative hypothesis. Step number 2, we select the significant level alpha based on the seriousness of McIntyre number 1 error. Step number 3, we're gonna use in the formula to calculate the test statistic. So you might use in the formula to calculate the test statistic, or you might just directly use in the shortcut, the 1 proportion z-test, to get the answer for that test statistic also. Yeah. Step number 4, we're gonna base on the distribution to calculate the p-values, or you can use in the shortcut to calculate the answer for the probabilities or the p-values. Step number 5, we're gonna compare p-values and alpha to get the conclusion. If p-values is less than alpha, we reject the null hypothesis. If p-values is more than alpha, we fail to reject the null hypothesis. And then after that, we're gonna go to step number 6 to answer the question of interest based on the context of the problem, which is there is sufficient, there is insufficient evidence. So that's gonna be the procedure for the hypothesis test in general, and we're gonna repeat this same procedure for all of the hypothesis that we will have in chapter 10, okay? So you might take a look at this summary or the procedure for the hypothesis test one more time, right? Before we take a look at the first example then. So let's take a look at the first hypothesis test of population proportion. Okay. So example number 1. So in the year 2015, about 66% of registered voters nationwide said that they were concerned about climate change. In the year 2018, a more recent survey asking 1,291 registered voters nationwide if they were concerned about climate change and find out 891 answer yes. So we survey 1,291 registered voters nationwide if they are concerned about climate change, and we find out that 891 of them saying yes. So at the alpha is equal 5% significant level, so this is significant level alpha, there's evidence to support the claims. There's evidence to support the claim of what? That the percentage, yeah, so the percentage of Americans who are concerned about climate change has increased in 2015. So in the year 2015, we have 66%. So this is the value that we want to test. So in the year 2015, we have 66%, and this is gonna be in terms of percentage, and then this has increased, right? So we want to test the claim that if this percentage has increased. Originally, in the year 2015, we have 66%. Now, based on the new data, based on the new samples of 1,291, we want to determine if this percentage has increased, okay? Okay, so this is gonna be the original population proportion. So this is gonna be P0. So this is gonna be the original population proportion, P0. This is gonna be the sample size N. So let me summarize the question real quick, right? So we know that this is gonna be the original P0. Okay. So that's gonna be 66% or 0.66. And we also know the sample size N is equal 1,291. We know the numbers of people with some certain characteristics is 891. And we know alpha is equal 5%. Okay. So that's what we have from the question. Okay. So based on the question, I can summarize what we have so far. Okay. So whenever you see the term that's there's sufficient evidence, there's enough evidence to support the claim, right? So this is gonna be a hypothesis test. So this is an indication of we're gonna do the hypothesis test. And this hypothesis for the percentage of proportion. So we do the hypothesis for proportion. And then in this case, we only have one sample with the proportion of registered voters who are concerned about climate change, okay? So this is the hypothesis. So let's do step number 0 first, right? So this is going to be the hypothesis for population proportion because this is percentage here. So now we're going to double check the condition first, right? So what's going to be the condition? So the first condition, make sure that we have simple random sample. Okay. So make sure that the 1,291 people that we selected right here, they're going to be at random, simple random sample. Now the second requirement, what is it then? So the second requirement is n times p0 times 1 minus p0 have to be more than or equal to 10. Okay. So let me copy that condition. Yeah. And then the third condition, the samples are independent. Yes, so the samples are independent, right? That's the third condition. Yeah. So the sampled values are independent. Yeah, so the sampled values are independent. So that's gonna be the three requirements that we need to check, right? So the first one, a simple random sample, that should be okay. The 1,291 people, we select them at random. Now the second condition, you might need to spend time to check if this condition, right? So you want to make sure that n times p0, 1 minus p0 have to be more than or equal to 10. So the sample size n is 1,291. And P0 is equal 0.66, and then we have 1 minus 0.66. You want to make sure that this calculation more than or equal to 10. Okay, is it more than or equal to 10? We have to find it, right? So let's use a calculator to multiply this and make sure that's gonna be more than or equal to 10. I will quit this. Okay, so we have 1,291 times it by 0.66 and then times it by parenthesis 1 minus 0.66. Okay. So that's going to be 289. Yeah, okay, that should be okay. 289.7004, which is more than or equal to 10. So this condition is true. Yeah, okay. So the first condition, simple random sample, we check it, they good. The second requirement, make sure that n times p0 times 1 minus p0 have to be more than or equal to 10. That's good. The third requirement, make sure that each individual that we selected in this sample, they're gonna be independent. Yeah, okay. So those gonna be the three requirements. Okay, so they are checked, we're good to go. Now, step number one, we're going to say the known and the alternative hypothesis, right? So the known hypothesis is going to be H0. And we're going to do the alternative hypothesis, going to be H1. Okay, so what's going to be the parameter for this hypothesis test, everyone? So make sure that you select the correct parameters, right? So this is going to be percentage or it's going to be proportion, right? So the parameter that we do for the hypothesis is proportion. The known hypothesis always equal. The alternative hypothesis, you might select some inequality for that, right? So what's the value for your hypothesis test? Yeah, so it has increases in 2015. So what's going to be the percentage in 2015? So we know the percentage is going to be 66%, right? So the P0 is 66 or 0.66. So P is equal 0.66. Now for the alternative hypothesis, we're gonna using the same parameter, population proportion. We're using the same value, 0.66, but what should be the inequality? Is that not equal? Is that less or more? So based on the claim we have right here, they're gonna say increase, right? So increase which is more, right? So increase which is more. Okay. So that's gonna be the alternative hypothesis. Okay, so far so good. Now, based on the alternative hypothesis, someone help me determine if there's going to be two tail, left tails, or right tail test. So this is the hypothesis of equal versus greater than, right? So this is a right tail test. Yeah, so this is going to be right tail test. Yeah. So we need to know the tails of the test because that affects the calculation for the probabilities. Okay. So that's going to be step number one, determine the known and the alternative hypothesis. In this case, we have right tail test. Okay, so that's going to be step number one. Now we're going to move on and do step number two then. So step number two, most of the time is the most easy step that you can do it. With a selecting significant level alpha and alpha is equal 5%. At the alpha is equal 5% significant level. So that's going to be step number two, selecting alpha. Yeah. Okay, so step number two is done. Now we're ready to move on for step number three, right? So for step number 3, we're going to calculate a test statistic by hand, or you can actually use a calculator later to double check this answer. So it's going to be up to you. Yeah. Okay. Okay, so this is going to be the formula that we have for the calculation of the test statistic z sub 0. Okay, so we do the calculation for the test statistic z sub 0. Now in this calculation, we need to find out p hash, right? So what's the calculation for p hash? So p hash equal x over n. So p hash is the sample proportion. And the sample proportion, we need to know the sample size. We need to know the numbers of individuals that have some certain characteristic. So we know x equal 891. We know n is equal 1291. So we can divide in there to get the answer for the sample proportion. Yeah. So p has equal 891 divided by 1291 minus p0. So p0 is the value in your hypothesis test, or the p0 that we listed earlier. This is the original proportion that we have for the test. So the p0 is equal 0.66. Yeah. Now divided by the square root of, and then we have a quotient here still. On the numerator, p0 0.66, 1 minus 0.66 divided by 1,291. So for this calculation, I will recommend that you have the parenthesis around the subtraction on the numerator to make sure that we have the answers accurate. Okay. Now let's use in the calculators, everyone, to find out what's the answer for the test statistic then. Okay, so I'm going to use a calculator. So I'm going to put the parentheses 891 divided by 1291 minus 0.66, close the parenthesis, divided by second square root of 0.66 parenthesis 1 minus 0.66, close the parenthesis, divided by 1,291. Okay. Oh, 91, not 94. Okay. Okay, now we're going to hit the enter key to get the answer then. Okay, so there's going to be 2.2878. Okay, so I'm going to use in 4 decimal place then, 2.2878. So it's going to be 2.2878. $2.2878, right? So that's 2.2878. Okay. So that's going to be the answer for the test statistic then. Okay, so now we got step number 3 is done. That's good. Now step number 4, we're going to calculate the p-values then. So for step number 4, you need to draw the curve and calculate the p-value. So before you can draw the curve over here, then you might need to take a look at the step number 1 to determine the tail that we have for the hypothesis, right? So based on step number 1, we know this can be right tail test then. So for the right tail test, make sure that I copy the right one. So this is going to be the right tail test. So this is what they mean by you might draw the curve. Yes, okay. So you might draw the curve. Okay, so the curve will look like this. So step number 4 is over here then. Okay, so this is the curve over here, and now you might need to locate the test statistic that we got right here. So 2.2878. So the z0s is a 2.2878. Okay. Now, in order to calculate the p-value, which means that we're going to calculate the area from 2.2878 on the way to the right. So because this is the standard normal distribution, so actually you can calculate the p-value using the normal CDF that we have earlier, or you can just using directly the shortcut 1 proportion z-test to get the answer for p-values. Yeah, so the p-values equal the probability that z more than 2.2878. Yes. And we're gonna use in the calculator to get this answer then. So let's take a look at your calculators, everyone. So based on the summary that we have so far, right, now we can use in the one proportion z test to get the answer for p-values then. So now we're gonna go to the stats option, we're gonna go to the test option, and we're gonna go down to option number 5, one proportion z test. Now, after we select the one proportion z test, you have to input the p0. So p0 is equal 0.66. Now x equal 891. And then n is equal 1291. And then for the alternative hypothesis, we're going to get the right tail test. So make sure that you go to the right tail test and hit the enter key to highlight that option. So this is what you need to input on the calculator. Okay. And then you're going to go down to the calculate and then just give me the answer from the calculator. So the first output is going to be the confirms of your alternative hypothesis. So proportion more than 0.66, which is the right tail test. Now the next output is the test statistic that we have earlier. So you might use in this shortcut, everyone, to get the answer for the test statistic also 2.2878. Okay. And the next output is going to be the p-values right here. So this answer is the p-value 0.0111. I'm going to route it to 4 decimal place, 0.0111. So that's going to be 0.0111. Okay. I'm going to just drag this answer over here to show you the answer, right, just in case. Okay, so that's how we got the answer for the p-value based on the shortcut one proportion z-test. And the shortcut one proportion z-test is also help you to confirm the answer for the test statistic that we have from step number 3. So actually for step number 3 and step number 4, you can actually just use the shortcut to get the answers, everyone. So you don't really have to calculate a test statistic. You might use directly the answer from one proportion z-test to give me the answers of these test statistics. Yeah, so make sure that you show me the shortcut and the input that you use it so you can convince me that this is how you got the answer for the test statistics and p-values. Yeah. Now that's going to be step number 4. We got the answer for p-value 0.0111. Now we are ready to move on to step number 5. Okay, so let's compare p-values with the 0.0111. And then alpha from step number 2, we know alpha is equal 0.05. So when you compare p-values and alpha, p-values is less or more. This is 0.01, this is 0.05. So 0.01 is less than 0.05, right? So actually in this case, we have p-values is less than alpha. Okay. So p-values is actually less than alpha when you compare p-values and alpha, 0.01, and this is 0.05. So 0.1 is less than 0.5, right? So p-values is less than alpha. So if we have p-values is less than alpha, let's take a look at the summaries over here. So if p-values is less than alpha, we reject the known hypothesis. Yeah, so we're gonna reject the known hypothesis. Okay. So that's going to be your conclusion. Yeah. So based on this sample data, we're going to reject the known hypothesis. So if we reject the known hypothesis, would mean that the known hypothesis is no longer true. It's not right based on the sample that we have. So that's why for the final steps over here, we're going to say there is sufficient evidence to conclude that. Yeah. So we have enough evidence to support the alternative hypothesis. Yeah. So there is sufficient evidence to conclude that the population proportion, that the percentage of Americans who were concerned about climate change has increased since 2015. Yeah. So we're going to say the final conclusion based on the alternative hypothesis. The alternative hypothesis is the one that we try to get the evidence to support it. Yeah. So because we reject the known hypothesis, which means that the known hypothesis is no longer true. That's why we say we have sufficient evidence to support the alternative hypothesis. Yeah. And then if you want to make the conclusion more complete, you can say at 0.05 significant level. Yeah, significant level. You just might need to add, mention alphas in your final conclusion. Yeah. So this is going to be the step-by-step, the hypothesis that we just completed for this population proportion. So you might take a quick look of the work that we have completed for the hypothesis test. Yeah, okay. So we're going to use the same idea for the rest of section 10.2 and then for the rest of chapter 10. And then from now on, whenever we do any hypothesis test, we're going to use the similar ideas also. Yeah. Okay, so once again, for step number 3 and step number 4, you might use a calculator. So let me show you how you're going to use a calculator or what is the work that you might need to show if you decided to use a shortcut to get the answer for step 3 and step number 4. So only step number 3 and step number 4, you might use a calculator to help you with the answer. The other step, you have to complete it on your own. Yeah. Okay, so now let's take a look at another examples, everyone. And then in this case, we're going to try the shortcut to get the answer for step number 3 and step number 4. Yeah. So when asked, what do you think is more important to protect the rights of Americans to have gun or to control the gun ownership? About 46% of American, okay. About 46% of all Americans say protecting the right to have gun is more important. A recent survey is asking 1,267 randomly selected Americans with a bachelor degrees and find out that 559 believe that protecting the right to have guns is more important. This suggests that the proportion of what? Proportion of Americans with at least feel differently. Yeah, so that's going to be the proportion. The proportion of American with at least a bachelor degrees feel different than the general American population when it's come to gun control. Using alpha is equal 10%. Yeah, so we are given alpha is equal 10%. So this suggests that the proportion of American with at least a bachelor degrees feel different than the general American population. So this suggests. So look like we're gonna do the hypothesis test for the proportion. Okay, so let's summarize the question again. So what's gonna be the original proportion as we have that? So originally the proportion of American who protect the right to own gun is 46%. So we'll see 0.46. In a recent survey, we surveyed 1,267 people, and we find out that among that people, we have 559 of them say they agree with the right to have gun, right? Protecting the right to have gun. And then we have alpha is equal 10%. Alpha is equal 10%. Okay. So this is going to be the summary of the question as we have. And then this is going to be difference. Okay. So this is going to be the hypothesis for population proportion. Okay. So before we can move it on, let's double check the condition again, right? So what are the 3 requirements then? So the first requirement, we want to have simple random sample, right? So that's going to be the first requirement. That's good. So we have 1,267 randomly selected Americans. So this is a simple random sample. So the first condition should be okay. Now the second condition, what is it? Let me copy the second condition then. So this is going to be the second condition. Okay. So the second condition, we say that the original proportion P0, oh, I'm missing an N. So N times P0 times 1 minus P0 have to be more than or equal to 10. So let's double check this condition then. So the sample size will be what? What's the values of N? So N is equal 1,267 times it by P0 is going to be the 0.46 or 46%. 1 minus 0.46 have to be more than or equal to 10. Okay, let's use your calculator to double check this condition, right? So 1,267 times it by 0.46. times it by parenthesis 1 minus 0.46. Okay, 314, 72, 28. 314, 72, 28, which is more than or equal to 10. This condition is true, right? So 314 was a more than 10. Yeah, 314, 72, 28 was a more than 10. So the second condition is good. Now the third condition, which means that the sampled value are independent. So I'm gonna use an independent condition because in this case, we don't know the population, right? So we're gonna use and make sure that the individual that we select, they're gonna be independent. They're not affecting the answers of each other. So that's gonna be the condition then, okay. Now, step number one, we're gonna determine the known and the alternative hypothesis, right? So I'm gonna copy what we have earlier, yeah. So for this hypothesis, we're gonna test for the proportion. So the parameter for your test is proportion. And the value for your test is gonna be the 46%. Yeah, so this is 46%. Now we have the similar value for the alternative hypothesis, but what should be the inequality then? Okay. So what should be the inequality that we have for the alternative hypothesis? So they say feel differently, right? So this is different. So it's not equal. Feel differently. So this is not equal. Now, based on the alternative hypothesis, can someone help me determine the numbers of tails for this test then? Is that two tails, left tails, or right tails? So this is the hypothesis of equal versus not equal, right? So there's going to be two tail tests then. Okay, so this is going to be two tail tests. So that's going to be step number 2. Okay, or step number 1. Now, step number 2, we select an alpha, right? So alpha is equal to 10% or 0.10. So that's the really much step number 2, the easy step in your hypothesis test, right? We just select an alpha. Now, step number 3. So you might use the formula to calculate the test statistic, or if you want to use the shortcut to get the answer for the test statistic, then that's totally fine. Yeah. So for those of you who want to use the shortcut to get the answer for step number 3, make sure that you mention the name of the shortcut with a 1 proportion. Yeah, so 1 proportion z-test. Okay. So after you mention the shortcut that you use it for the calculation of the test statistic, you have to give me the value that you use it for the calculation. Okay. Okay. So x equal, what is that? X equal 559 and n equal 1267, right? That's really much. Yeah. So take a look up the shortcut then. Yeah. So we're gonna go start and we're gonna go to the test option. We go down to option number 5, 1 proportion z-test. And then the P0s, I can tell the P0 from your step number 1, then you don't have to repeat that. So it's gonna be just show me, yeah, 46. Sorry. Now x equal 559 and z equal 1267. And then for the alternative hypothesis, I can tell that from these alternative hypothesis. Also, this is two-tailed test. So make sure that you select the two-tailed test, and after that, we just go down to the calculate. Okay. Okay, so using 1 proportion z-test with x equal this and n is equal this, now you can plot the answer z sub 0. Okay. So what's the answer for the test statistic also? So the test statistics is negative 1.3427, negative 1.3427, right? 3427. So that's the answer for the test statistic, z sub 0. That's the z right here. And then using the shortcut, 1 proportion z-test is also give you the answer for p-value, right? Okay. Using 1 proportion z-test to have p-values equal the probability. That's because it's going to be two-tailed test, right? So it's going to be 2 times, yeah. So make sure that you copy the summaries over here, right? So this is the two-tailed test, so p-value is equal 2 times the probability that z more than absolute values, yeah, okay. So the absolute values of the test statistic, the absolute values of this is going to be 1.3427, yeah. 1.3427, and that's going to give you okay, so make sure that you mention the name of the shortcuts again, right? And then just quote the answer from your calculator. 0.1794, yeah, 0.17. So that's going to be the answer for the p-values, okay. So using the shortcut, the one proportion z test, that's going to give you the answer for the test statistic, z sub 0. It's also give you the answer for p-values, okay. Now, step number 5, we're going to compare p-values and alpha, right? So p-values equal 0.1794, and then alpha from step number 2, we know alpha is equal 0.10. So this is 0.17, gonna be more than 0.10, right? So 0.17 is more than 0.10. So whenever we got p-values is more than alpha, what's your conclusion then? So take a look at the summaries if you don't remember it, yes, right? So if p-values is less, we reject. If p-values is more, we fail to reject the known hypothesis. Yeah, so we fail to reject the known hypothesis. So whenever you say that you fail to reject the known hypothesis, would mean that the known hypothesis is still true, right? That's why you fail to reject it, would mean that the known hypothesis is true. If the known hypothesis is true, which means that the alternative hypothesis is no longer true. So that's why we're gonna say there is insufficient, yeah, to conclude that the proportion of American with at least a bachelor degrees feel different than the general American when it's come to gun control. Yeah. Okay. So we just copy the alternative hypothesis. Yeah. And if you want to make sure it more detailed, you can say at 0.10 significant level. Okay. So once again, this is going to be the hypothesis test that we conducted together. So once again, this is the hypothesis for the population proportion. Okay. So you might take a look up the works again. So once again, we have a shortcut that you might use it to get the answer for step 3 and step 4. So everyone, if you want to use it, you are more than welcome to use it, right? So just show me the name of the shortcut and show me the input that you use it for the calculation. And after that, we just quote the answer from the calculator. Yeah. Okay. So this is the output that we have from the calculator. The test statistics is negative 1.3427. The p-value is the next output right here, 0.1794. Yeah. So this is the second example how we perform the hypothesis test for population proportion. Yeah. Okay, we have one more question to show you, right? So once again, before we can actually perform the hypothesis test, you need to double check the condition. And the 3 conditions we have the first requirement, simple random sample. The second requirement, n times p0 times 1 minus p0 have to be more than or equal to 10. And then the third condition, the sampled values are independent, right? So the sampled values are independent. So that's going to be the 3 requirements that you need to check first before you can actually jump to step number 1 of the hypothesis test. So what happens if the second condition is not true? So which means that there are some cases, this means that the sample size is not big enough. So how we going to do the hypothesis when the sample size is not large enough? So that's gonna take you to the next objective, which is so test a claim about the population proportion with a small sample size. So this is the small sample size. The sample size is not big enough, so that's why the second condition not true yet. So for the sampling distribution of P have to be approximately normal, we require that n times P0 times 1 minus P0 have to be more than or equal to 10. What if this requirement is not met? So if this requirement is not met, which means that the distribution for the sample proportion P has is not normal. So that's why you cannot use the normal distribution to calculate the probabilities or the p-values. So we're gonna use the binomial distribution rather than the normal distribution to compute the p-values. So we're gonna use the binomial distribution, binom CDF, to calculate the probabilities or the p-values. Yeah. So this is gonna be the procedure that you use it for the hypothesis when the sample size is small. So step number 1, double check the condition. Okay. Step number 0, double check the condition. Step number 1, determine the known and the alternative hypothesis. Step number 2, select the significant level alpha. Step number 3, we're going to calculate the p-value. You don't need to do the calculation for the test statistic. We just calculate p-value using the binom CDF calculation. So if we're going to get the right tail test, then this is how we calculate the p-value. We're going to do p-value is equal 1 minus binom CDF and px minus 1. If we're going to get this is going to be left tail test, then the p-value is equal the binom CDF and px. Okay. So if the sample size is small, then you don't need to calculate the test statistic. We're just using a binomial distribution to calculate the p-values. After we got the answer for p-value, then we're going to compare p-values and alpha. If p-value is less than alpha, we reject the known hypothesis. The same rule of conclusion. If p-value is less, we reject the known hypothesis. If p-value is more, we fail to reject the known hypothesis. So that's going to be the same rule for conclusion. P-value less, reject. P-value is more, fail to reject. And then step number 5, you just answer the question of interest based on the context of the problems. Okay. So that's going to be the step-by-step. That's how we perform the hypothesis for the population proportion when the sample size is not large, when the sample size is small. Okay, so let's give you one practice question, right? We relate with this objective then, okay? So this is going to be example number 3, okay? So in the year 2006, about 10.5% for all of the live births in the US were to mothers under 20 years of age. A sociologist, okay, so this is the original percent, we might need that. A sociologist claimed that this percentage is decreasing since then, okay, so this percentage decreasing. She conducted a simple random sample, yeah, so she got a simple random sample of 34 births. And find out that 3 of them were to mothers under 20 years of age. So test the sociologist claims at alpha is equal 10% significant level. So test the claim. What's the claim? The claims is this percentage is decreasing. So what's the original percentage? The original percentage is 10.5%. Yeah, okay. So if you want to summarize this question again, so we have the original P0, the original proportion or percentage, 10.5%, 0.1005. The sample size n is equal 34. And then among that, we have x equal 3, and we have alpha is equal 10%. So that's going to be the summarize of this question. So this is the hypothesis test for the proportion or percentage. So let's double check the condition. Okay, so the first condition, simple random sample. Do we have that? Yes, we have it, right? So she conduct a simple random samples of 34. So this condition should be okay. Now the second condition, is it good? So n is equal 34. times it by the original proportion 0.105 times it by 1 minus 0.105. You want to make sure that this answer is more than or equal to 10. Is it true? So we have 34 times it by 0.105 times it by parenthesis 1 minus 0.105. This is 3.19. Yeah, okay, it's only 3.19515. So this condition is false. Okay, so the second condition is not good, right? Because the sample size is not big enough, so that's why we cannot use in the normal distribution. The sampling distribution for the sample proportion is not normal. The sample size is less than 5% of the entire population. I'm gonna say this is yes, because we only selected 34 mothers or 34 births. That's gonna be less than 5% of the entire population. So the first condition, okay. The last condition, okay. The only problem we have is the sample size is not big enough. So that's why the second condition is not true. So because n times p0 times 1 minus p0 is less than 10, we cannot say that the sampling distribution of the sample proportion p has is approximately normal. Yeah, that's not good. Yeah, so we cannot assume that. Yeah. Instead, we must use the binomial distribution. Yeah. Okay. So we just check the condition, and then the second condition is not good. So that's why you cannot use the normal distribution to calculate p-value. You have to use the binomial distribution to calculate p-values then. Okay. Okay, so that's step number 0, check the condition. Now step number 1, we're gonna say the known and the alternative hypothesis. So let me copy this. Okay. So we're gonna do the hypothesis for population proportion. So the parameter we test gonna be proportion. What's the value for your test? What's gonna be the original proportion? We have 0.105 or 10.5%. Now, what's going to be the inequality that we use for the alternative hypothesis? Not equal, less or more. So a sociologist believe that this percentage is decreasing, right? So it's going to be less than. Okay, so decreasing, so it go less. So this is the test of equal versus less than. So this is going to be two tail, left tail or right tail. So this is going to be left tail test. So that's going to be step number 1, determine the known and the alternative hypothesis. Now, step number 2, we select an alpha, right? So this is the most easy step. So alpha is equal 10%. We know from the question, alpha is equal 10%. Yeah. Now, step number 3, we're going to go directly to the calculation of the p-value. So let's take a look at the formula to calculate p-value, right? So based on the alternative hypothesis, we know this is going to be left tail test right here. This is left tail test. So let me copy the formula. So if we have left tail test, then this is how we calculate the p-value then. Okay. Okay. Now x is going to be 3. I'm just replace x equal 3 right here. So p-value is equal the probability that the x values is less than or equal 3. Okay. So I'm going to use in the binom CDF calculation. We need to know the sample size n. The sample size n is 34. We know the probability of success in this case 0.105. And then the x value is equal 3. Okay, so now we're gonna use in the binom CDF, everyone. You gotta remember how we access the binom CDF, right? So we're gonna go second var and then access the binom CDF. Yeah, so binom CDF. The numbers of trials is 34. Success rate is 0.105. And then the number of success we want to get is 3. Okay. Okay, so that's going to be 5149, 5149, 0.5149. So that's going to be step number 3, calculate the p-value. Now, step number 4, we're going to compare p-values and alpha then. So p-value, that's we just got it from step number 3, 0.5149. And then alpha from step number 2, we have 0.10. Okay. So when you compare p-values and alpha, p-values is less or more. So p-value is 0.51 and then alpha is equal to 0.10. So p-value is more than alpha, right? So p-value is actually more than alpha. So let's take a look up the way that we say the conclusion. Whenever we have p-value is more than alpha, what should be your conclusion about the hypothesis then? So if p-value is less than alpha, we reject. If p-value is more, we fail to reject the known hypothesis. Yeah, so fail to reject the known hypothesis. Yeah. So if you fail to reject the known hypothesis, would mean that the known hypothesis is still true. Would mean that the alternative hypothesis is not true at all. So that's why for the final conclusion, we're gonna say there is insufficient evidence to conclude that the percentage is decreasing since then. Yeah. And if you want to be more specifically, you can say at 0.10 significant levels. Yeah. And if you want to be more specifically, the percentage, this percentage, you can be more specifically. Yeah. So the percentage of, the percentage of on live birth in the US were to mother under 20 years of age. If you want to be more specifically, the percentage of what? Yeah. That the percentage of on live birth in the US were to mothers under 20 years of age is decreasing since then. Since then, what's it then? Since the year 2006, yeah. 16, yeah. 2006, okay, 6. Okay, so that's how we say the conclusion, okay. So there is a possibility that you might need to use a binomial distribution to calculate the probability when the sample size is not large enough, okay. So this is gonna be the third example that we have for this recording the hypothesis test of population proportion. And then we have two possibilities when the sample size is large enough and when the sample size is small, okay. So once again, the idea for the hypothesis is step number 0. So step number 0 for the hypothesis test, you're gonna you need to make sure you need to check the condition. Step number 1, you're gonna determine the known and the alternative hypothesis. Step number 2, you need to select the significant level alpha. Step number 3, you might use the calculators or using a formula to calculate the test statistic. And step number 4, you're gonna use the distribution and maybe the shortcut to get the answer for p-values. Step number 5, we're gonna compare p-values and alpha to get the conclusion of either reject or fail to reject the known hypothesis. And then step number 6, you're gonna answer the question of interest based on the context of the application. There is sufficient or there is insufficient evidence to support the alternative hypothesis. So that's gonna be the end of the recording for the hypothesis test of population proportion. So you might stop the recording at this point and try some homework question related with this recording, the hypothesis test for population proportion. I will see you next time for the next recording. Yeah.